Well, I'd like to welcome everybody here today for talking about exploring the Mid-Infrared Galactic Center with SOFIA legacy maps. I'm Dr. James Radomski. I'll be instrument scientist for Forecast, the mid-infrared, far-infrared slash imager slash spectrometer for the SOFIA airplane. With me also is Dr. Nicole Carneth, who's also instrument scientist for Forecast. And today we'll be talking about some kind of a newish project for SOFIA, which is these legacy projects, these much larger projects to go much more in depth in some of the science rather than these smaller projects we've been doing previously. So, first slide. So here is a very nice composite image of some Galactic Center data from both SOFIA, Spitzer, and Herschel. So you can see from the image lots and lots of stuff going on. The white is Spitzer 4.5 micron data. The blue is SOFIA 25 micron data. The green is SOFIA 37 micron data, and the red is Herschel 70 micron data. So this is a 4-color composite of the Galactic Center. This survey was one of the first legacy programs for SOFIA, done in cycle 7. To give you a hint, we're starting cycle 9 very shortly. We're just finishing up cycle 8. So this was the cycle 7 project, observing a total area of about 400 arc minutes, square arc minutes, including Sagittarius A, B, C, and the Arches complex. This mosaic was combined with previous data. The arches, as you can see kind of at the central top of this map, were from guaranteed time from the Cornell group, and we're observed in cycle 3 and 4. More information about this legacy program can be found at this link, the SOFIA link about the legacy program, the Galactic Center, so you can find some details there. The data for SOFIA 25 and 37 microns, these full mosaics, are fully available in the archive right now. The link to access them at the ERSA archive is also included here. And all you have to do is search for the plan ID 07_0819 and look for the level 4 data. Level 4 data is our composite mosaic data. So the level 3, if you want to look for individual fields, you can check level 3 and it'll give all the individual fields for this survey. If you want to look at the Arches data, which is older data, you have to put in the older plan IDs 7003 and 7004 listed before. So there's been an overview paper kind of discussing the initial data release, which was in January of this year at the previous WS. And Hankins et al. 2020 AppJ article right there. So you can go there, download that. I'd highly recommend that. That gives you kind of an overview of the data, some highlights, some zoom-ins of interesting regions and stuff, and some discussion. The Hankins team, of which I'm also a part, is still working on this data set and also trying to publish a few more papers on some different areas and stuff. But of course, the data is free for anybody to look at and anybody to work on and start doing science on. So now, first of all, why did we look at the Galactic Center? I mean, the Galactic Center is a target that everybody certainly have looked at before, and certainly is one of the first things every telescope looks at. Of course, there's many reasons to look at it, and first I'll go over the observational regions. For one, in the mid-infrared, 25 and 37 microns, it has not been looked at very much. In fact, 37 microns, I believe this is the first 37 micron map of the Galactic Center. And as for the 25 microns, 20 microns region has been looked at before, but previous data has had some issues. For example, here's the top data. You can see basically our composite map of SOFIA data. You see, we didn't get necessarily everything. We basically picked out the most important regions along the Galactic Center to save time. But here's our map at the top, and the full width map resolution is around 3 or 4 arc seconds. So below is MSX band E 21 micron data, which was previously observed, which covers the Galactic Center. You can see the highlights of our regions overlapping, which did a very nice observational survey. But of course, their full width half max is around 20 arc seconds for this data. So we've improved tremendously as far as separating and different individual targets and avoiding confusion. Now, Spitzer, which has a resolution of approximately 6 arc seconds with MIPS at 24 microns, did a very nice map, of course, of this region. They also did it at 8 microns as well. But the 24 micron MIPS map, as you can see, these white regions right here, especially in this very center and at the edges and stuff like that, all these white dots are completely saturated. The Galactic Center is very bright and such, and Spitzer just was not able to get a lot of information of the most interesting regions just because it was saturated. So doing these observations with SOFIA provided a tremendous amount of data in a region of the spectrum which just has not been observed either at all or certainly not with this resolution. Now, why would you look at the Galactic Center scientifically wise? Well, I mean, it's a fascinating region of star formation, similar to the center of luminous infrared galaxies near the peak of the star formation epoch. So if you want to study star formation in the early universe at this peak in these luminous infrared galaxies, which are far too far away to really resolve and such, looking at our own Galactic Center as a prototype is a very good start. So it's good to compare that for extragalactic research. Also, a significant fraction of star formation in our galaxy is contained in this Galactic Center region, approximately across 1.3 degrees of sky. So, and there's lots of questions to be answered. The star formation rate, although very high in this region, is much lower than you would expect, possibly on order of magnitude by some estimates, lower than you expect based on the amount of dense molecular gas. So there's some curious things going on as far as why this star formation seems to be relatively suppressed in this region. Other reason to look at it, why we look at this in the mid-infrared specifically, is of course you avoid a lot of the extinction in the optical and the near-infrared. I mean, you've seen optical images of Galactic Center, it's just basically a dark lane. Well, we see through that lane in the mid-infrared. It wavelengths 25, 37 microns, also traces the peak emission of young stars, especially young massive stars, which peak closer to the far infrared, while balancing the resolution. So we get better resolution in some of these longer wavelength studies that have been done with smaller telescopes in the far infrared. It's also helpful in distinguishing models of massive stars and such. So Spitzer 8 micron maps are very nice, but of course they're dominated more by pH emission. And seeing this emission on these objects continue on to larger wavelengths can help distinguish models of young massive objects and stuff. For example, here's a region of the Sagittarius B complex right here with a combination of the IRAC 8 micron in blue, SOFIA forecast 25 micron in green, and 37 micron in red. And you can see there's lots of different structures here, color on. You can see to the left very dark red regions that were highly embedded, which didn't show up so much into Spitzer 8 microns, and blue regions to the right. You may not be able to see so much to the right, but there's a green circle over B1 parentheses A, which is a massive star forming region and such. So along with lots of wispy and interesting emission and stuff, as well as bubbles and such going on. And so looking at these wavelengths really help pin down, star formation. You can use it to estimate some ages sometimes when you compare it with other data, such as CO data and models of virial parameters and such. So similar research has been done on the other SOFIA data, such as M17 and other star formation complexes and stuff, and it's being done on this Galactic Center. So, analyzing the data. Well, once again, you can download the data right from the archive right now. I've given you the links. You look at URSA, you put in the plan ID, check level 4. You can download 2 maps. Here's an example of DS9, just on one of the maps right here. And if you go to the SOFIA data documents page, we have examples with a handbook discussing the data, calibration of the data. We also have some Jupiter notebooks going examples of actual reduction and aperture photometry documents and stuff. So everything you need to know, including if you want to look into other stuff about spectroscopy, there's some models there. The imaging is pretty simple. It's all calibrated, fully calibrated in Janskis and such. So it's a 3D cube with one plane and image, the second the noise, and the third is the exposure. But the noise is mostly just the measurement and Poisson noise. The calibration uncertainty is really the dominant issue with the flux. So, and those range from about 5 to 10% at these wavelengths. So, which is on par for what you expect in the mid-infrared. So, I think historically we got about an average of about 6% variability in the calibration, which is the dominant error. And here's an example right here where I just brought up Mosaic and DS9. Plopped an aperture over on the target and just got all the parameters I needed, including a flux of 24.24 Janskis. So it's pretty easy to analyze and start looking at regions right away. So some important data notes, though, is The forecast pipeline has been going forward. We have been making tweaks and advancements in the pipeline, and we're changing somewhat the file format of the data. This is something for future. All old data, including this data, is in the old format, which was based on an IDL routine for the pipeline. It has now been written in Python, or reimagined in Python. And the current data, like I said, and all the forecast data previously has been in this old format, so you don't need to change anything. However, a new format going forward is going to change slightly to FIT's format. It's going to be more compatible with a lot of different software programs and such. It's no longer going to be definitely 3 dimensions. It's going to be fit in a nice more 3 prefixes and stuff like that in the data. The planes will change slightly. For example, there's always an imaging and noise and exposure map plane. However, I think just the order have been changed slightly, so the imaging and noise may be in different order. And the noise, rather than a variance sigma squared, has been changed to just sigma. So, and this will all be outlined in the future as future data comes out and stuff, and new handbooks and new reduction techniques like that. So it's really a minor change, but something to keep track of going forward in case you take more forecast data. There will be slight changes coming up. So, and this may also come up because there's possible follow-up of a few missing Galactic Center regions. As you saw, we did a lot of interesting spots, but there are some, small parts that we probably could do. So if we do a new Galactic Center map, we'll have a re-release of the data, and that will be in a new Python format probably. So just a heads up for that. Some other heads up on the data. Of course, it's fantastic data, but not perfect. There are some astrometry issues with the forecast. We do have some slight distortion issues, which we're trying to model out on order of a few pixels or a few arc seconds and such. So if you download that entire massive data set of over 30 fields and stuff, and you line it up with all your data, if you start seeing some small offsets and stuff, you might want to recheck that and stuff. It may need to be realigned and stuff, because we try to align it as best as possible with previous maps of data, Spitzer and other wavelengths and stuff. But there still could be some offsets in some regions and such. So just be careful, because some of those offsets are real, because there's real effects at different wavelengths where sources can shift. But there's also some astrometry issues. So you just want to make sure you're taking account of that. So, and we are working on solutions for future data, so we don't have an issue anymore. So, but that's just something to keep track of. Also, unfortunately, we did have some issues during these flights. We had several flights doing that. And during some of the flights, we did have some smearing in the Galactic Center field. So there'll be some point sources that are slightly elongated in some regions. I believe that's highlighted in the Hankins paper. You can look at that to discuss all the issues with astrometry and any problems with the fields and such. So that's a good start, is download that paper with the data and just review over it and stuff. So, and of course, you can ask any questions and stuff to the SOFIA help desk, and we'll certainly help you through that and follow up. So finally, I just want to once again wrap things up. Once again, there's a beautiful image. Here's the links to get the data. For example, you can once again download 2 files, level 4 data, get the 2537 micron maps. If you want to look at the individual files, just make sure you download the level 3 data, which are the calibrated individual files. The level 4 is the full mosaics. So there's the link to the Hankins paper. In addition, there'll be, I believe, a webinar Wednesday at 1 p.m. Eastern and stuff. Here's the link with SOFIA, where we're introducing archival funding proposals. So you can actually apply for funding to actually look at legacy data or any other data in the archive. So you can actually look at this data, which is free right now, and get paid for it. So that's a very nice option. Other legacy programs are listed here on our SOFIA website. You can go there for more information. Like I said, we are trying to follow up with the Galactic Center with a few more fields to finish it off, but we've also gotten some great data. It's C2 maps of the Galactic Center. We are thinking about following up with Hawk data, with polarization data. We already have that in Sagittarius A. I think from previous observations, but we're trying to do some more mapping of the region and polarization. So there's plenty of data upcoming and stuff on this project and similar projects. So with that, I'll leave it to questions. So does anybody have any questions?
All righty, thank you. If anyone wants to unmute themselves, go ahead and do that, or ask your questions in the chat box. So far, I don't think I see one in here. No.
James and I will both be at the SOFIA exhibit booth later today too as well, if you want to pop in there to ask any questions.
Yes, feel free to stop by anytime to the exhibit booth, which also has a list of all our talks. And I think there's a webinar later today by Jim DeBiser talking about SOFIA science in the afternoon and such. So we have plenty of things going on. So feel free to stop by the booth to check on that. And certainly, like I said, Nicole will be there, and I'll be coming in and out and stuff. And we can reserve time to chat over the Galactic Center data or any SOFIA data you may have or questions you may have. And of course, there's the SOFIA help desk email, which you can send to and request any information you want.